We're live and on the air. Okay. Let's see what we have. Oops, I gotta change this thing. Why did it go back and change this? Alright, now we're ready. We have two lines. Now, they're not just any two lines. Remember these little arrow things? What does that mean? Angles? If I put two little arrows here on these lines, it means they're parallel, right? If I put two little arrows right there, it means those two lines are parallel to each other. Okay, so what we're going to talk about today only works if you have parallel lines. Everybody with me on this? So these are our two parallel lines. What are do you remember what the name of this thing was that crossed those parallel lines? It starts with a T. Good. Transversal. Very good. All right, so our transversal. So here's what we have. You had a whole bunch of theorems in geometry that said if you have two parallel lines cut by a transversal, then blah, blah, blah. All these things are true. All right? So let me put some numbers in here. I'll call that 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm not going to be super concerned that you know the names of the relationships between these. If this was geometry class, straight up geometry, then I would make it a pretty big deal. But I just want to make sure that we know the relationships as far as what angles are equal and what ones aren't and all that kind of stuff. But we will say this. Look at 1 and 5. Do you see 1 and 5? 2 and 6. They're kind of in the same place. Do you see this group of 4 angles up here and this group of 4 down here? This angle 1 is in the top left corner, and this angle 5 is in the top left corner of that group. Do you see it? So they kind of are in the same spot. Or we say that they do what to each other? Do you remember what that stands for? Starts with a C. They correspond to each other. Good. Okay, they're corresponding angles. So 1 and 5 are corresponding. 2 and 6. What are some other ones that match up? 3 and what? 7 and 4 and 8. Do you see those? See, I've got this group of 4 up here and this group of 4 down here. 1 is in the top left corner on that group. 5 is in the top left corner of that group. So we call them corresponding angles. Now there's a relationship between corresponding angles. Take a look at it. Look at angle 1. It's this big obtuse angle. Look at angle 5. It's an obtuse angle as well, isn't it? So they're going to be equal to each other. We're not going to go through all the steps on why or anything like that, but they are. They're equal to each other. So corresponding angles are equal. You got it? What about 2 and 6? They're going to be equal to each other as well. 3 and 7 are equal. 4 and 8 are equal to each other. You got it? Look at the other ones. Look, 1 and 5 we said were equal to each other because they're obtuse angles. Right? Well, not because they're obtuse angles, but the obtuse angles are equal to each other, and guess what? What are these angles? The acute angles, they're also equal to each other. So really, I just look at this. I don't even have to know all the different names. I don't have to know that corresponding angles are equal. What was another one? We had alternate, remember that one? Alternate interior angles, they're equal to each other. Do you remember that? Okay, that kind of thing. We had same side interior. We had all these different names for it. I'm not that concerned, okay, that you know all the names for it. But I do want you to know this, that all the obtuse angles are equal to each other. So what angles are equal? Let's write them down. So angle 1 equals, what else equals angle 1? Let's just list them. Okay, angle 5, right? Which equals angle what? 4, right? Angle 4. And what else? Angle 8. Good. Okay, take a look. 1 and 5 are equal to each other because they're corresponding angles. Look, 1 and 4 are equal to each other because they're what? We learned this yesterday. 1 and 4. What's the relationship between 1 and 4? They're vertical angles, right? So 1 and 4 are equal to each other. Look, 4 and 8 are equal because they're corresponding. You could say 1 and 8 are equal. This is one that's a little bit more obscure, but 1 and 8 are equal because they're alternate, not interior, but what do you think? Exterior angles, okay? So there's all kinds of reasons why these are equal to each other. The easiest way to look at it, though, is just say, hey, look, all the obtuse angles, they're all equal to each other. All the acute angles, guess what? They're all what? They're all equal to each other, okay? So let's write down the acute angle. So angle 2 equals what? Angle 3, which equals angle, what are other ones? Angle 6, and what's the other one? Angle 7. So they're all equal to each other. You got that? So these are all your obtuse angles, and these are all your acute angles. And they're all equal to you. Okay, the obtuses are all equal and the acutes are all equal. Now, let's take a look at this. Look at this one. This is obtuse, and this one right here is acute. What do they form? We talked about that yesterday. 180 degrees. That's right. What's the name for it? Give me a Yeah, that's right. I almost went the other way. You're right. It's supplementary. They are supplementary to each other. Okay. So an obtuse angle in this situation and an acute angle, no matter what combination you have here, are always going to be what to each other? Well, they're not always going to be. Look, this one right here, this obtuse and this acute, they're not adjacent to each other, but they're not equal. An obtuse can never equal an acute, can it? No. So what are they? We just said it. Right, they're supplementary. They're add up to 180. It's the same thing, right? They add up to 180 or they're supplementary. So I could list those out if you wanted to. So 1 plus 2 equals what? 180. 1 plus 3 equals what? 180. 1 plus 6, see? 1 is obtuse, 6 is acute. So what do they add up to be? 180. Follow me? And you don't even have to know all the special words for it, do you? All right? Just know that the obtuse angle, you might want to write that down in your notes, the obtuse angle and the acute angle are supplementary to each other in this situation. Now, you have to have parallel lines cut by transversals, not just any old lines cut by transversal. They have to be parallel to each other. You with me on that? All right. What if we had this? What if I didn't know that these lines were parallel to each other, but I did know that 3 and 6 were equal to each other? Well, they're both the acute angles, aren't they? All right. If 3 and 6 are exactly the same, then guess what must be true about the two lines? They got to be parallel to each other. Okay, that's kind of like the converse. It's not kind of, it is exactly. It's the converse of what we'd said before. Make sense? Is it coming back to you now about lines, parallel lines, transversals, all that good stuff? Now again, we could go into a whole bunch of stuff and write all those words out. We could write out the words alternate interior angles, corresponding angles, alternate exterior angles, same side interior angles, blah blah blah, all that kind of stuff. But I think it's a lot easier, don't you? Just looking at it and say, hey, all the obtuse angles, they're all the same. All the acute angles, they're all the same. And if I take an obtuse and an acute, there's no way they're going to be equal to each other. So what are they? They are supplementary. Make sense? All right, that's an easy way to look at it. All right, well, we covered quite a bit there. Now, if you look in the book, they list all that stuff out, and they tell you all the names of them and all that good stuff. But that's good enough for us. All right, let's pause this and let's draw another picture. All right, here's a different situation. Now, these three lines right here, I should have, I guess I can do it right here. Watch. Put a little arrow here, and a little arrow here. What does that mean about those three lines? Talk to me.
Parallel.
You're right, they're parallel to each other because those arrows right there. Now, you can't make any assumptions. If those arrows were not on there and you just saw that picture, don't make any assumptions that, oh, well, they look like they're parallel to each other, so they must be. You can't do that in geometry, all right? So don't assume that they are parallel unless something tells you that they are. Those arrows are something that does tell you that they are equal to each other. So what we're going to do is we're going to put some, I'll tell you what, let's go different color. How about that? We'll go, this will be exciting. All right, so we'll say that that is 3, that is 4, let's say that is 6, and we want to find what that's equal to. Now look, if this is 3 and 4, is this equal to this? Is 3 and x equal to each other? No, because like 4 and 6 aren't equal to each other, because look, this is tilted. This is going to be a little bit longer, isn't it, than this one right here, because it's slanted a little bit more. But what we have is we have a ratio. We can set up a ratio between these. You can set up a ratio a couple different ways. Watch. I could set it up like this. I could compare. That's what a ratio is a comparison. I could compare this segment. You know what the 3 is? It is from here to here. You know that, right? I just didn't want to make any assumptions. All right, so from this point to this point is 3. From here all the way down to here is 4. So, right, we could... You got it. So if I go 3 to 4, then I can compare x to 6. That doesn't mean 3 and x are equal to each other, does it? All right, because 4 and 6 obviously are not equal to each other. But I can make a comparison like that. I can go 3 to 4, and then I can go x to 6. I could do it another way. I could go left to right. I could go compare 3 to what? X. So if I can compare 3 to x, what am I going to have to do here? 4 to 6. Good. Now here's one way. And you could go opposite. You could go 4 to 3. If I compare 4 to 3, then I would have to go what?
6 to x.
Right, 6 to x. You follow me on that? All right. I cannot do this. I cannot compare diagonally. I can't compare 3 to 6 is 4 to this. You follow me on that? Okay, you can't compare diagonally. You can just go either up or down or across like this. You could still go x over 3, right. You could go backwards of this, right. You can go 3 to x or x to 3, but this would have to be 6 to 4. Exactly. You got it? So there, say it. Because that's not the rule. The rule says you can't do it like that, okay? Yeah, you can only compare this segment to this one or this one to this one, okay, and the other way. I can't give you a great answer for that, but you can't do it that way, all right? So let's do this. Let's solve for x. Cross multiply, or watch, x is already on top, isn't it? So watch, just multiply this by what? 6. You see that? So x is, what do we got there? 18 over 4. Or look, what goes into both of those? 2 goes into that 3 times, into that twice. What do we got? 9 over 2? Yeah. Or what would that be? 4.5? Yeah. So that's what that would be right there. That would be 4.5. You could write 4.5 if you want. You could write 4.5. You could write 9 over 2. I don't care. That's all you do for that. It's pretty easy, isn't it? All right, good deal. All right. Let's actually stop this one because we're getting close to our time limit, and then we'll start another one. And we've got some things about area, and we're getting close to done this lesson finally.